Now we do the second problem, and let's call fx to be x minus floor of x. This is called floor of x, which means the greatest integer which is less than or equal to x. Let's see some examples. If x is integer, say a positive integer 4, then floor of 4 will be 4. If x is a negative integer like -2, then floor of -2 is -2, because a greatest integer less than or equal to that integer itself is that integer itself. Now if x is value which is bigger than 0 and it is not an integer, then how would floor x looks like? So let's consider example. X is 2.5, then floor of 2.5 will be, what's the greatest integer less than or equal to 2.5? 2. On the other hand, if x is -1.5, then the greatest integer less than or equal to x will be -2, because if you see on the real line, -1 lies here, this is -1.5, this is -2. So greatest integer less than or equal to -1.5 will be -2. Okay, so let me clear out the space a bit. Alright, so now we can easily solve this efficiently also by plotting the curve. So I'll draw y-axis, the x-axis. Now note that when x is integer, then x is same as floor of x, correct? So the value of f for any integer is 0. So at x equals 0, 1, 2, 3, 4, or -1, -2, -3, fx is 0. Okay. Now let's see what happens between 0 and 1. So when x is between 0 and 1, what is fx? Fx is x minus mod of x. And if x is between 0 and 1, then floor of x is 0. So the curve is x. And between will look like this. But there will be a hole at this point, because f of 1 will not be equal to 1 as it is shown by this equation, but it will be 0, because note that f of x is equal to x only when x lies between 0 and 1 and is not equal to 0 or 1. Okay. So now what will be for x between 1 and 2? Between 1 and 2, not taking values at 1 and 2. Well, f of x would be x minus 1, because the greatest integer less than or equal to any value in this interval will be 1. And what is the curve look like? Well, it will be also straight line with which has a slope of 45 degree, starting at x equal to 1, and again there will be a hole. So like this we can extrapolate that for all between all integers the curve will be like that. How about for negative values of x? Say x is between -1 and 0. fx will be x minus of 1, because the greatest integer less than or equal to the value of x between this interval is -1. So it is x plus 1. And hence the curve will be like this. Again, there will be a hole at this point, which is corresponding to y equal to 1 and x equal to 0, because when x equal to 0, the value is 0. Similarly, we can plot the curve for other intervals. Okay, so it's an interesting kind of curve which repeats at integer intervals. So now what we are interested is the right hand limit at x equal to 1. Okay, so as we approach intuitively, as we approach x equal to 1 from this direction, the y approaches the value 0. So intuitively 1 plus of x minus floor of x is 0. If we want to do a little bit rigorous, then this will be equal to limit of h tending to 0, 1 plus h minus floor of 1 plus h, and greatest integer less than or equal to 1 plus h is 1, so limit of h tending to 0, 1 plus h minus 1 is h, which is 0. So actually we didn't have to draw all this curve, we could have just gone through this step and we would have proven the limit 0, but it's okay. It's interesting to see the curve also, how it looks like. Hence we have solved the problem.